Hello, good evening. Welcome to this episode number 11 of the series by Ozzy, Amiga Game Dev, and we talk about his racing car game that he has been showing all his, let's say, adventures in doing this game. It's episode 11, so yeah, he made 11. um, Soon he will make 12. So let's welcome Ozzy. Hello, Ozzy. Thanks for being here.
Hello, thank you. Thanks for having me.
So, as I was saying, this is episode 11 of the series. Um, we haven't had one for the last 2 weeks because Ozzy was away. Um, he was having fun at work, right?
Yeah, it was not that bad actually.
Yeah.
I,
So,
I'm quite happy when this happened.
okay, that's good. So yeah, we continue with the series. Also, I need to apologize for last Sunday that I didn't stream, but I should be streaming next Sunday, this coming one. So yeah, things happen, no? Sometime life gets into the middle, as always. Anyway, so let's start with the usual prayer, as I call it. Please like and subscribe to my YouTube channel and follow all the videos there. I mean, they are not always the latest because they go to Patreon, but of course, after a while, they get updated here. Remember that under each video, I should stop that and go to the beginning. Let's say this better. And under each video, there is this more button that gives you links to the video sources, the sources related to that stream. The sources are Omega when the video is released, but Patreon, those that are on Patreon Coffee, they have access to all the sources before they go public. Besides YouTube, of course, I have my Facebook blog page, let's say that, where I post everything that I'm doing. Usually Tuesday I do not post, so I do not make an advert of the stream. I do not get time. Like today, Ozzy can confirm I was working quite late, so I didn't have time to post any links in relation to this stream. Unfortunately, I would like to post to advertise the stream, but I do not get the time. So, like the Facebook page, I have the Facebook group. So please join the group or join the Commodore Dev group, which is anything related to Commodore. As you have noticed, for those that has joined, this group is growing and growing, and there is always new stuff there. And in a way, it's got a name now, I think, more than anything. Because in recent months, it really grew more than I thought. Besides that, you can send me messages on Facebook. I do take my time to read them, but if you join my Discord, you can. I will reply much more quicker. Let's say that. If you don't like Discord or Facebook, then I have Telegram. You can join my Telegram group. All links are in the upper right hand corner, or you will see a link appearing in the chat from Linktree, where you can see all the links related to Phase 101. For those that want to go the extra mile, let's see where it is. It's still showing 106 videos, but actually yesterday to my Patreons, I showed them about 10 videos that have been uploaded. I just need to make them available. Hopefully I will do that tomorrow. But if you subscribe, if you want to go that extra mile to help us, then you unlock 106 videos or more related to development. And same thing on coffee. It's they are a mirror of each other, basically. Also, I want to remind you that there is a game jam going on between myself and Retro Programmers Inside, which is the Retro Tank Game Jam. Please have a look if you want to participate. You're still in time. Besides that, on itch.io you also find all the games for the previous game jam, those that were released, because some of them are not yet released. But once they are released, they do get updated here. So, like for example, we did the racing cars. Where is it? Where are the games related to the racing car? I think some. Here they are. Sorry. So once that is done, once Ozzy finishes his game, it will be updated here.
You will have to wait.
Yeah, it's okay. It's okay, but you know, it was part of the gem, so it will get updated there. So yeah, I do not think I have anything else to say. I think I covered all. You notice some changes behind me also. I had to reorganize the room a bit. I still haven't finished, because if you look there behind me is clean and all stuff, but if you look on this side, it's a mess. But anyway, and even the shelving, it's not yet ready. Too many things. So yeah, let's pass. Today it will be everything in browser so far. So we will start. I'm just preparing the slides from the beginning. We can pass to basically Ozzy. There you go. So there are the slides.
Yeah.
Unfortunately, our images are going to cover part maybe of the slide, but because we are using the browser, I cannot do better. Normally, when I use Acrobat, I can hide that. I can sort that out, but with the browser, it's a different story. Anyway,
yes,
let's start.
Yeah, let's talk about programming, and we will talk about video games next time if you want. I'm not so expert in video games, but I remember something, so I can talk about it. I was telling that I did nothing. So the game is exactly the same as the end of May, no major updates. So what I'm going to talk about today is just what I think before going to bed. This is just my time when I start thinking, how could I implement this? How can I make the game as I want? And honestly, I have something to show. I have the box of the game. It's homemade.
Oh, yeah.
I don't remember. Oh, it's here, I think. Let me check. Yes. This is from my friend. So this is a very rare limited edition. Let me check. Can you see it?
Yeah.
It's upside down.
Yeah. Well.
So
Yeah, you
this is
move it a bit further down, move it down. Yeah, there.
like this.
Yeah. And show all sides of it. Show all sides of it. Yes, that's cool.
Yeah, I think it's a serial box, nothing more, but it's still very limited edition because only one copy in the whole world. So it means I can sell it on eBay for 1,000 euros at least, according to what I see these days on the on eBay and other marketplaces. But yeah, thanks to Carlo who did that. And
Is
maybe
he here today? Is he going to watch you?
I think he is currently watching us.
Yeah.
Probably yes. Maybe later we can have a talk with him. I don't know if he's
Yeah,
available or
sure.
not.
Yeah. If you're listening, hello.
Okay, so what I was saying, since I did nothing, I will talk today about what I think before going to bed. So this is the last feature that the last major feature that I want to implement. And I left this for the last feature, let's say, because I don't know if this is something that I can do it, because I don't know how to do it properly. And there is a great chance to fail, but at least I want to try it and see how it goes. And so the last feature is making the CPU driven car. So I want the CPU to play. So it's not just a multiplayer human game. I want you to compete with the CPU. And the CPU should be able in every situation to detect where it should go, and if the car has. I have this dream is to have this car, self-driving car, like the Google car. And in order to do that, I try to think about how could I implement this. And of course, this must be a way that should allow me to hit the 50 frames per second. So it must be a very simple algorithm. I'm not looking for perfection. I'm just trying to limit the cases when the car gets stuck in some corner of the track.
Mm-hmm.
So it's not important to me to achieve the perfection and not to have different levels of CPU, so a very skilled automated drive or some weak. Just the goal is to have this car that successfully completes at least one lap. This is my goal, and this is what I'm trying to do right now. And it's not working at all, right? But I did something, and in this stream I will talk about what's the idea behind this. Just a proof of concept. Okay, so let's go to the second slide, and I will talk about more about how to do this. At least what's the idea behind. And can you go to the second slide, please? Page number 2.
I am on page number 2.
Okay, I fell behind on the stream, so no problem. I assume that it will. I will watch. Okay. So the idea is to have these red dots on the. Of course, they are not visible on the screen, so you won't see them. But still, I want to put all the coordinates of these red dots, which I called hotspots or destination point, as you prefer. I want to spread all these points on the trajectory of the car. So the idea is to point the car to this these points. And whenever they approach closer and closer, they just go to the following point. And the idea is that following this path, it's just this path projection, it should be able to complete one lap. So there is if you probably already know that I have this book here, which is The Nature of Code. And there is a whole chapter that talks about autonomous agents. And autonomous agents in this book are treated like autonomous entities that behaves independently from each other. They don't have a leader. They just follow his own logic about how to act. And for me, the acting is the decision where the path that they have to take. And there is a long discussion in this book that more or less is my same idea with these hotspots or destination points. The problem is that, of course, here there is a lot of math involved. And so if you are a math teacher or you know a lot about math, please go away because I'm going to blaspheme a lot today because it's not an easy subject for me. I don't remember a lot about math and trigonometry and the linear algebra, but this is what the book, so the Nature of Code book is referring to. So I had to study again linear algebra in order to understand the very basic concept. Additionally, the book is using AProcessing framework, not AProcessing, so it's much easier to compute the path of the car. I have to do this extra work in order to re-implement the same functions, the same concept. And of course, in order to re-implement this stuff, I have to have at least a little bit of knowledge of trigonometry and linear algebra. This is why I say, please don't take my word for granted. Double check what I say because probably it's wrong. I remember at school I was very bad at math. So big disclaimer, and don't yell at me if I get wrong. So another difference that I have with the book is that the book is just teaching you how to calculate this vector. It's called desired vector, so the vector that the car should follow. And instead, what I'm looking for in this case, I want the car to move exactly like a human being. So I don't want to calculate the vector in order to get the car in path. My output should be, okay, you have to steer right or left, or accelerate or brake. And then, according to this, the output will be then crunched by the engine, the game engine, and will produce the car movement. I don't want to force the car movement because it will be very easy to say, okay, this is the current car location, and this is the desired destination. I can just replace with a move.w or move.l the coordinates, and I would have this car teleported to the next point. This is not what I want. I want just a replacement for the read joystick routine that gives the same exact output, but it's driven by the CPU and not by the joystick. This is the goal. So at this point, I would like, if it's possible, to run the game. And I gave you my, let's say, pre-made compiled version just for you. in order to show an example of what I'm doing. So you have to launch the game, and without doing anything, just go straight into the game, and the first car, so the red car, should move automatically.
Hold on. So I am in
And
your
remember-
directory. I'm in your directory. Let me. So
And you should have RC32.
yeah. Yeah, and should I start the game?
Okay, you go into start game, so the first option,
Yeah.
without changing any option, of course, without changing anything. You just go straight into the race.
Okay. What I didn't check is which joystick I have plugged in. So
doesn't matter, because all I want to show is the car which is able to move automatically without your input.
Yeah. Okay, let's see. Start race.
Yes, start race. And the race should also auto start.
So I'm seeing the red car going. I mean, it went somewhere. It just got stuck.
So this point is pre-calculated. Try to hit the red car if you're able to do it.
I'm controlling a lot of cars. That's the problem.
Isn't the problem? But you have to hit the red car.
Yeah, I did.
With one of yours.
Yeah.
And you should notice that the CPU controlled car is trying to go towards the same point every time.
I think it tried to go the previous point. So for some reason,
so I just set up one point. The idea is when you reach this point, you go to the second, the third, and so on.
Yeah, you see, I'm pushing it, but it's still going backwards because it's trying to go to the first point.
Yes.
Yeah.
Because that's expected. This is my current implementation. For now, I'm not doing path following. I'm just doing a seeking of a point. I want the car to seek a point.
Yeah. Okay, I understood. Yeah.
Okay. So right now you can exit the game, and you can open the Visual Studio Code. We can do some live debugging, because I didn't try this at home actually. So there is a high chance to fail.
So give me a second. Yeah. I have your the assembly commands, but
okay, you have to look for the input routines directory.
Let me make it bigger first.
And inside this directory, there is a file which is called CPU control.s.
There you go.
Okay, so at the top, still okay. Yes, I see now. There is mover destination X and mover destination Y at line 8 and at line 10. So this is the point that the car is currently seeking. And if you notice, the coordinates are X equal 80 and the Y position is 50. So these are coordinates relative to the upper left. So 0, 0 is on the upper left of the screen. So I didn't check it actually, but it seems to me that the car was seeking that region of the screen. So maybe there is a chance that it's working in some way.
No, it's trying to get to that point.
I would say let's see what happens if you change the values. For example, the mover destination Y you can change from 50 to, for example, 30. And I expect that the car should point to a point which is
further up.
Upper.
Yeah.
Yes, it should be upper because the Y is inverted. So if you decrease the Y point, you should go up.
Let's make it smaller. Let's make it 20.
Yeah.
So
I don't know where this point is.
Yeah, whatever. Yeah, it doesn't matter. So
save. Remember to save.
It is saved.
And you have to recompile.
Yeah. I did it. So let's run it again.
Yeah, you have to do it from scratch.
Yeah.
And let's hope it won't crash.
Can you exit from the game or not?
Yes, you have to press ESC, but it takes too long. I usually just press Ctrl F4 and close the window and restart the emulator.
No, it went out. Okay, sorted. Yeah, it's fine. So, and now, let's see, 32. Start.
And let's hope it works because this is totally untested.
Let's see. I'm not going to touch anything. It should move by itself, no?
Yes, you controlled, I think, all the 4 cards.
Yeah,
but
it went up. Yeah, it's trying to go into the people.
Yeah, of course, this is responsibility of the author of the track. He has to provide these points which are correct, because if you put a point outside the track area, of course the car will get stuck.
Yeah.
So
but it's a good test. Now we have shown that it can go upwards and try to follow the point. Let's say that.
Let's try just one last test and change the X position and put 319.
Okay.
And see what happens. I expect that change
tries to go down.
Yes, it should go to the right, so in backward direction.
That's it.
And put as a reference the Y should be 42.
So Y you want me to do? Y should be 42.
Yes, it's the starting position of the car.
And the X, what should it be?
Let's try with 300.
300.
This one, I think I will fail for sure.
Okay, so now I need to assemble it. Okay, assembled. And let's run it again. I did not show the assembling, but you can.
Yeah, I trust you.
Yeah, you can. Start. So now it should go backwards.
Yeah, to the right of the screen.
Yeah, but it's going to clash with the other cars, no? Can it move backwards?
Okay, it can crash with the others. You can control the other car with your joystick.
Yeah, Look, it turned and it went backwards. It's going backwards. Yeah. It did it. Of course, it crashed with the cars, but yeah.
Yeah, it's trying to reach this 300 point to the X. So this is good news. It's not guruing. It's a start. I would say that I'm not stating that the seeking is working, because I have to do further checks, because for me right now it's hard to understand if it's pointing exactly at this point that you set on the source. But still something is telling me that I'm on the right track. So
Yeah.
I'm very,
It's
happy.
okay.
This is a very good news. Thank you
Yeah.
very much. You bring luck to me.
Yeah. So shall we switch to the slides?
Yes. So what I'm going to do right now is to talk about some boring math and just explaining how I did this path seeking, because it's not so trivial for me, because I don't know math, because when I was young, I, instead of going to school, I prefer to play soccer, play football. But now I really need this knowledge. And I had a colleague who was a teacher, a math teacher, and now he resigned. So I'm really on my own. So if any of you knows linear algebra, please get in touch with me.
Okay, Hound Dog. Ciao. Have a nice evening.
So go to page number 3, and of course, bye Hound Dog, also from Italy. So this is the main problem for me right now. Where to steer? Since this is a top-down game, I only have 2 ways of steering. I can steer clockwise or counterclockwise. So my routine, the first thing that should tell me is if I should rotate backward or not, clockwise or counterclockwise. In order to do this, this is my sketch that I did before going to bed. And the idea is the following. I painted 2 black lines, and they are marked with V3 and V4. And these are my vectors. So V4 is my destination vector, is the position where I want the car to get to relative to 0, 0. And V3 instead is the position of the car relative also to position 0, 0. So these are my 2 vectors. And V3 is already known because the game, of course, the game engine has to know where to paint the sprite of the car. So this is something that I don't have to figure out or to add additional code to calculate, because I already have it on my variable in memory, of course. But V4 is the problem. I don't have it. This is something that a new concept, and I will retrieve it from the track file or a separate file, but this is what the author of the track should give me as an input. And according to this, I will figure out V2. And V2 is just the vector that points from the car position to the final destination. So it's the path that ideally the car should follow. How do I get this destination vector? And this is quite straightforward, I would say. In order to get V2, you just have to make the difference between V4 and V3. And you should get a new 2D vector that will give you this V2 vector. And already AProcessing has some macros, some routines that allows you to do vector subtraction in all these fancy ways. You can only have to pick the right version. When you have this V2, the V2 vector, you have to figure out what's his angle. And here starts the problem, because I don't have the angle of this vector. I first have to calculate the vector, and then I have to figure out which angle is this vector. There is another angle, which is the A-car angle, an angle car, which is painted in red. And this is something that I already know, because if you remember, the way I paint the car is relative to an angle, because of course, if the angle is 0 degrees, I paint this car sprite that correspond to 0 degrees. I don't rotate this sprite. I just have multiple images for the same sprite. So the same car is painted over and over for every angle. So in order to select the correct sprite, I have first to get the A-car angle, and according to this, I have to paint the correct sprite. That's how it works, and I think also I explained this, I don't remember when exactly, but last year it was when I implemented all of this crazy stuff. So
It was
the
not
main
in,
idea.
it was not in this series. It was in the AProcessing series. No?
No, it was in the car series, because I explained how I
The
produce
vectors.
sprites.
The vectors, you mean?
No, I was referring to how do I paint the correct car image.
Oh yeah. That was episode number 2, actually.
Because I have an image, a sprite image for the car at degrees 0, and I have another, for example, at degrees 90, and another at degrees 180.
Yeah, I thought you were explaining the vectors. So sorry. No, nothing.
No. I just want to state clearly, because that it's not the same picture, which is rotated pixel by pixel doing some sort of math. I just painted the same car over again at different angles, and that's how it works.
Yeah. It's episode 2, I think, or 3.
Yeah, it's one of the first for sure.
Mm-hmm.
But all of this just to say that I already have this A-car angle, because without it, I can't paint properly the correct sprite. So my only problem now is to figure out the V2, so I call this APOS, angle position. So it's the angle of V2. And this is where the pain starts for me. And in the following slides, I explain how I solved this, or at least how I think I solved this, because still I'm not so sure that my math is correct. But the idea is that just comparing these two angles, so the A-car angle and the APOS angle, I can figure out if the car has to move clockwise or counterclockwise.
Mm-hmm.
This is the idea. And on the right, I wrote, it's just one of my notes, one possible implementation of the algorithm that tells you where to rotate, comparing these two angles. So I start comparing if APOS is greater than the A-car, I put it AC, but it's A-car. Then I check if the absolute, the value of the difference between these two angles is minor the 180, so it's pi. In this case, I steer counterclockwise, else I steer clockwise. On the other case, so if APOS is less than the A-car angle, I do the opposite. And this should tell me exactly where the car should steer. So this is the idea. I don't know if it works, but this is what I implemented when you saw the car pointing, seeking the point.
Mm-hmm.
So in order to to get this angle, this APOS angle, this is what I did. I have to open a subtopic which is about vector multiplication. So I know it's boring, but you have to stay with me. I will make things as simple as I can. So please go to page number 4. And this is an image which is taken from the nature of code. And for me, it's perfect because Daniel is so good at explaining things that really I can't do any better. This is a vector multiplication, and this is what I already had on AProcessing. And this is in vectors, there are different types of multiplication. This is the most simple one, and it's just a scalar multiplication. It means that, for example, we have a vector which is 3. The magnitude is 3 units, let's say. And if we want to multiply the vector, we are just changing the magnitude. We are multiplying the magnitude by 3. And this is done with my mul2d vector 1/2 macro. And it's very simple. I just take the x value and I multiply it with the, and I take the d1. So let me start again. I take the x value of the vector and I put into d0. I take the y component and I put into d1. Then I have this scalar value that tells me how much you want to multiply, and I perform the multiplication using mols.w. And the same stuff occurs with the y component. And then I put back the result in memory. Just remember that multiplication is not fast on the Amiga. It's a pain, but you have to do it sometimes. And this is one of these cases. There are other ways. You can just repeat add in some cases when, for example, you want to multiply by 3, for example. But this is just a generic routine. And remember that often generalization is against speed on the Amiga. So this is a slow routine. I'm not suggesting to use it. This is generic. It's just a template for you in order to work on this. I use this at the beginning. Then when I'm close to finish the project, I'm quite done. I start to optimize and I change this. I make a copy of this macro and I just strip what I don't need. But so this is not about optimization. I just want you to say that this is how I multiply vectors. But there are other ways to multiply vectors. And please go into the next page, and you will see that there is another product which is called the dot product. And it's another type of vector operation, and it's quite common on linear algebra. And again, this is another image taken from the nature of code, and it's just telling us that you can do the dot product with this simple formula, which is the x component of vector A times the x component of vector B plus the y component of vector A times y component vector B. Of course, forgive me if I'm saying this because I take it for granted, but multiplication have precedence over the plus, the addition sign. So you have to first do the multiplication, then the result of the two multiplication, you have to put together and do the addition. And this is an example of a dot product that we have vector A, which is -3 and 5. We have vector B, which is 10 and 1. So the y component is 1, and x is 10. If you do the multiplication, notice that you don't get another vector, you get a scalar value. So you have a single number is the output of this operation. And this number is quite useful for a lot of reasons. One of them is it allows us to discover the angle of this vector. So it's, let's say, a building block of the formula of the vector, to get the angle of the vector. On the right, I put my implementation in AProcessing of this formula. And it's this time it's not a macro, it's a function. And it's specific to the Q106 format. So it means that the number I'm expecting the number to have this particular format. So the last 6 bits are reserved for the decimal part, and all the others, the 10 bits, are for the integer part, and the most significant bit is the sign. So it's a very specific usage. Of course, all this complexity is hidden on the modern PC. You don't have to figure out all this stuff. You have the FPUs and this fancy stuff going on. But yes, on the Amiga, you have to deal with this problem, because you all have to remember that every cycle can transfer 16 bits. And so you have just only 16 bits if you want to go fast. And in 16 bits, you have to represent your number. And this is what I'm doing right now.
Yeah. Can I stop you a second? Just for curiosity more than anything, since you have been reading about it. This formula, okay, we have seen it at school back in the days. So this vector A product of and multiplied by vector B formula, is it always written like this, or there is other ways of how it is written?
There is at least one other way, and you can see it on the next page.
Okay.
So turn the page and you will find the other formula.
Yeah, there you go. Because this is what sometimes confuses me personally. They are talking about the same thing, but they write it in a different way.
So again, this is you see that in the first 2 lines there are 2 different formulas. So the first one is
but my question was more, so I'm going to go back to the previous one. Okay. Yeah. So this formula that we have here, the product of a vector A plus and vector B.
But okay? You have also on the next slide the same exact formula.
Yes, and there are different formulas for obtaining the same result. But the way it is written here, let's take this formula only, okay? With the A and the vector on top of it, and B and the vector on top of it. In mathematics books, is it always written like this, or it's written differently sometimes? The symbols vary, or it's always like that?
For what I know, the symbols are exactly like that, because you have to put the arrow on the front, on the top of the
Yeah.
letter of the vector, and this represents a vector,
Yeah.
not a single variable.
Yeah.
And of course, you can use any letter you want. You can call them Pippo and Pluto and Paperino. That's no problem.
Yeah.
But what's important is that the concept that the product, the sum of the product of these two entities gives you the dot product.
Yeah, but what I'm trying to say is, for example, okay, let's say A product of B is written like that. But then what's on the right? Is it always written like that?
There are other formulas in order to achieve the same.
No, not the formula. There are other formulas, as you're saying, but the way that formula is written, with the A and then the X times BX plus AY times BY, is it always written like that? Or they use other letters?
As I said, these are just letters. You can replace them as you want. On my book, it's always written like this.
Yeah.
On the nature of code.
I know that, but what I'm asking is, I thought maybe I came across it. If you take another maths book, if it's always written like that, also in maths books, with the AB,
I think there is a great chance that they will use always the same notation, because it's some sort of standard. If you're referring something in particular, just tell me.
I need to check it, but yeah, this is something that sometimes confuses me. But anyway.
But this is not important. So you can use whatever notation you want.
It is not important, but if you know it with A and B, then if somebody uses something else,
A and B are just vectors. You can call vector A, you can call it vector 1, you can call it vector Pluto, or whatever. It's not a big deal for me, actually. But anyway, let's continue
because I do not want to confuse you or to. It's just that I'm just curious to understand if there are other ways of writing the same formula, basically.
Okay, so here on the second line, I repeated the same exact formula. So vector A dot product vector B is equal AB plus AB. Okay? On the first line, there is another formula.
Yeah, which is...
And this means, so that A times B dot product is equal to the magnitude of A times the magnitude of B times cosine of theta. So these two lines just represent two different ways to get the same result.
Yeah.
Okay. Actually, there is a demonstration online. I found it. Still, I don't fully understand why is that. I just take it for granted because my math book is stating this stuff. So for me, it's true. So since this is true, you can just replace it and get the formula on the third line. So AX times BX plus AY times BY is equal the magnitude of A times magnitude of B times cosine of theta. So this is trivial to me. They just replaced the values.
Another stupid question. What do the bars mean?
The bars, the double bars, are the magnitude.
Okay, the magnitude of the vector A, basically.
Yes. For example, go back to page number 4. So yeah, I take for granted that you know what is a magnitude of a vector.
Yeah, but the symbol for it I had forgotten, so that's why I asked you.
Okay.
I have forgotten that it is the double bar. So
Okay. Okay. This is the magnitude.
yeah.
So how the length of the vector. Let's put it
Yes,
in
yes,
this
yes.
way. So if you read the last line, it states that cosine of theta is equal to a dot product b, so the ab dot product, divided by the magnitude of a times the magnitude of b. And this is another way to express this formula. They just use the fact that you can divide the left of the equation and the right of the equation to the same value, and the equation will still be true. This is something that I still remember. They taught me.
Yeah.
And now there is the last part of the formula is hidden by you, but I will
Sorry,
read that for you.
I can. This is why I didn't want to do it here. Let me do one thing. Hold on a second. 10, 10, 10, and let's switch. You see, that's why.
Okay, now it's better. So there is this last line, which is theta is cosine elevated to -1, and then the same stuff again. So a multiplied by b divided by the magnitude of a times magnitude of b. This cosine to -1, and this is easy, I remember that. When you elevate to a negative number, to -1, you are doing the reverse of the fraction. In Italian is reciproco, penso. Reciproco. We call it reciproco.
No? You're doing the opposite, no?
The opposite, it's different because from 2, the opposite of 2 should be -2. I don't remember. But in this case, you just to switch the numeratore with the denominatore.
Yeah, so the negative of a number. I don't know.
Yeah. So you are doing the inverse function, essentially. Yeah. But the inverse function of cosine is called arc cosine. At least in Italian is arco coseno. I don't know in English how they call that.
It's arc cosine.
Arc cosine. So essentially, this arc cosine function will give you exact what we are looking for. It's giving us the angle of this vector between these two vectors, the A vector and B vector. So this is the math behind all my code. I'm just trying to represent this and asking my Amiga, please give me the result of the arc cosine of the dot product from vector A and vector B divided by the magnitude of A times the magnitude of B. And if you use a modern PC or with any programming language, this is a one-liner. If you use the assembler, this is the hell. And I will assure you, this is when I spent all my weekend just trying to represent this line in assembler. And in this moment is why I understand Pellicus when he states, okay, do some stuff in C, and then you move in assembler when you want to do real complicated stuff, because this is a lot for the Amiga. The Amiga has not, so the CPU, the M68 CPU has no concept of cosine or arc cosine, has not concept of the magnitude of a vector, has no concept about anything of this. So I have to make some tricks in order to get not the most accurate result, but still something that it's near the result, the real result. Okay. So in order to figure out something, please go to the 7th page, and this is what I came up with. I state that my b vector is 1, 0. So x component is 1 and the y component is 0. So this is just something that is parallel or coincident with the, I don't know how to say in English, axis, x-axis.
Mm-hmm. Yes, x-axis.
And so doing this simplification makes things a lot easier for me and for my program. The same formula can be written with theta is cosine, so the arc cosine, and then you open the bracket and say ax plus times 1, and of course every number that is multiplied by 1, it gives you the same result. And then you add ay multiplied by 0, but any number that is multiplied by 0 just gives you 0. So all this part can be just written as ax. And the other part is the magnitude of a and 1, because of course the vector b1 has magnitude 1. So very good simplification. We have theta is equal to arc cosine ax divided by the magnitude of a, and this will give you the angle between vector a and vector 1, 0. So it's the angle between the vector b and the x-axis. And this is a good value that I can use to compare with the car angle, because the car angle that I have is relative to the x-axis, so the line with y equals 0. That's my point. So all this stuff is just to simplify things, because the processor can't handle this. Or at least it can, but remember that I have to repeat all this procedure over again, every frame for each CPU controlled car. So it must be as small as possible.
So the did you create tables with the arc cosine and cosine, etc., for the Amiga?
Not only. And this is the hard part, because you can create tables, but tables takes memory.
Yeah, of course.
And chip RAM is precious. So,
but they do not need to be in chip RAM, these two. They can be fast RAM.
But this table is quite small. Guess why? Because my numbers are in a Q6 format. Yeah, this means format. That, and if you remember, the cosine function just gives you values between -1 and 1.
Yeah.
So I use only 6 bits for representing this value. Of course, they are not 100%, but still, this is something that is usable for the game.
Mm-hmm.
So the table, it's just 1 byte, 1 entry for each of these 6 bits. And 2 elevated to 6 is 32, and plus multiply per double it for the negative. So you just end up, you get away with some 100 byte table, something like that. It's not a big deal. This is not a big deal. You can do it. And I did a small C program that gives you the table as output. It's very trivial. It's not a problem. The problem is what you will find in the next slide. And I think it's page number 8.
Right.
And you should see
The square root.
image.
Yeah.
Yeah. So let's say that we have, this is it's a possible scenario. Of course, it's not likely that it will happen, but in theory, it can happen. So if you have, for example, the car on near the top left of the screen, and the destination is on near the top right of the screen, we have to figure out the distance vector, which is represented by the orange line or the yellow line. And in order to get the magnitude of this, you have to use Pythagoras. And Pythagoras says that the x multiplied by x plus y multiplied by y, all of this result into square root gives you the magnitude. And this is something that we study at school very early. It's trivial. The problem is that in this case, I have to do 290 times 290 plus 210 times 210. So this is a very big number. The number is 128,000. This number will overflow our 16-bit variable. So it means that d1, d0.word, it's not able to represent this number. We need extra bits. And in AProcessing, there are some routines that I took from GitHub that allows you to calculate, to compute in real time the square root. They are very heavy, and additionally, they only work with 16 bits. So in this case, they will fail. I don't know. I didn't try it because it makes no sense to try it. In the instructions, they state that you have to use a word and not a long.
Mm-hmm.
So I went with the lookup table approach. But in order to represent all these combinations, you end up with a very big table because you have to, each entry of the table must represent a square root. So it's a 2-byte. So square root of 0, square root to 1, square root to 2, and you go on until you arrive to 122,000, etc. And if you do the math, and I did it above, you end up using half of your chip memory just for this table. If you do this, it means that your game
why
won't
are you
have music.
Why are you saying chip mem? Why are you, this table should be in fast mem, no?
Yes, but I'm targeting a stock Amiga. Stock Amigas don't have fast RAM.
Okay.
Of course, if you have fast RAM, things are completely different.
No. I thought you were targeting standard A500 with 512K expansion also, not just 512K.
I'm targeting an Amiga 600.
Mm-hmm. So,
but taking into account that my game without this table is taking more or less 350 kilobytes. Then in the future, I plan to put the music, and it's some other chip RAM, of course. So if I put this table in chip mem, I'm very, very near the threshold. Maybe it fits, maybe not, I don't know. But remember that also the operating system, even if it's disabled, it's taking you some memory.
Yes, so you are aiming for the A600. The A600 has got 1 megabyte or 2 megabyte, I forgot right now. 1 megabyte of chip mem, right? And you can make it 2 megabyte of chip mem.
You can with the expansion, yes.
Yeah. So if you're aiming for an A600, okay, then an A500 is 512K chip, 512K fast mem if you have it expanded. So
Yes.
you are still in the same water, let's say that. But if the table is so big, are you saying that you will run out of, if you have A600, you have 1 megabyte. Are you saying you're going to run out of that 1 megabyte of memory? Or that you're going to run over the 512K chip mem?
I'm stating that there is a possibility that this table will fit in 1 meg, yes. But problem number one, this is here in my calculation, I just took this situation, but the worst case scenario is 320 times 320 plus 240 times 240, which is even a big number. So it means that 250K won't be enough. Let's say I need 300K, okay? The point is, I don't want to waste all this memory for a lookup table. I want to use this memory for my music, for my graphics, for other stuff. Maybe there is a way to save this memory. And of course, you have to do compromises. And I was looking for a compromise here. I say, okay, I don't want to give you all this memory, but still I'm willing to accept some error if it's small, but in return, I want to save a lot of memory. Because I'm not willing to give you 350K of cheap RAM or whatever RAM, because I can't afford it. In the future, I want to add music. And I don't know when the music will arrive. Usually a mod file is 100K, 200K, 300K, I don't know. Usually these are the size of a mod file.
Yeah, but for games normally they stick to 50, I think. When you're talking about standard, I think 50, 60. I think normally that's what they do.
Yeah, since I don't have this file because my musician didn't produce this, I want to stay as cheap as possible. Additionally, right now, the game is working on a stock 500 without expansion. If you run this on just only half meg chip RAM, it should start. And if possible, I want to hit this target. I don't think it will be, but I want to try. It will be very nice to have this game running on an unexpanded 500. So, but anyway, this is just a method I want to tell you how to solve this problem. Of course, you are free to use a very huge lookup tables if you want. I just want to tell you, I found this method, and you can use it if you want. If you don't like it, just don't use it. So, and my method is the following. There is a property on the radicands of the square roots that states that the square root of a times b is equal to the square root of a times the square root of b. And this is something that I found on my math book, and I completely forgot about it. And using this property, I state, and of course, this is a mistake because it's not true, that the square root of a very big number divided by 4 times the square root of 4 should give you not exactly the same result, but you should be very close to this. And this is my point. So I give you some error because when I'm dividing by 4, I will lose some bits because I'm shifting bits to the right. So the last 2 bits are lost. But in exchange, I can use a simple lookup table. And this lookup table will just fit a word. So I have a 60K, 65K lookup table instead of 350. And in return, I lose some precision, but it's good to me. I don't need all of this precision. I just want some idea how the angle is. That's my point. And of course, I do the square root of 4 because that's the number that I used to divide before. And because it's multiple of 2, it means that I can use the right shifting in order to divide. So shifting 2 bits for the Amiga is not a big deal. It's something that it's common usage. So this is something that for me it can be used on my game. And again, I want to underline and shout, ring bells, whatever. This is wrong. This is not a math theorem. This is the the square root of a big X. It's not equal to the X divided by 4 times square root of 4, but it gives you a good result. And if you go to slide number 9, which is the last one, is the table that I'm using and the current implementation of my square root. And this is a macro. What I do is I just load the address of the square root table into A0. I clean D1, and then I check if I'm overflowing or not. If the number that I want to perform the calculation is equal or greater than 65,536, then we are overflowing, and I will just divide by 4, take the result, and then multiply by 2 using a simple lsl.w. If the number is smaller, no problem. It fits on my lookup table. I just return what I found in the lookup table using move.b a0d0.l, and I put the result into d1. And this is how I calculate very big square roots. And of course, this is a routine which is taken from AProcessing, and I adapt according to the cases. There is also in this slide a screenshot of what I used to create the table, which is on the Amiga font editor website. I just click generate, and boom, you get all these huge tables with a lot of comments.
Yeah,
and that's it. I will say I really hope I didn't bother you too much with all this.
This is the web page that Ozzy is talking about. His web page where you can generate.
Yeah, you just click to generate, and it will generate for integers.
Yeah.
It takes a while because it's very spaghetti code, even if you have a fast computer.
And for those that do not know it, I mean, I've pasted this many times, but I'm going to do it. So I'm just going to switch back to the to Acrobat. And
yeah, nothing much to say. This is essentially a short summary of what I think before going to sleep. Probably I'm crazy, I know, but really I had this intuition just before getting to bed.
So, first of all, hello Proton. I'm reading your messages now. And Proton was kind enough to share square root, optimized square root formula. Give me a second, I will show it. So maybe you can use it in your game.
If it's better than mine, of course. If it's faster,
I think it is very fast. Give me a second. That's the whole routine.
I don't see it because I'm.
Give it time.
But okay, this is not a lookup table.
No. It generates the square root. You give it a long, and the output is a word. This is what
yes,
we say.
But I don't think this is faster than mine because there is a cycle here.
I don't
VBNE, it means that it's iterating.
Yeah, well,
we can just do some comparison.
You need to, yeah. I think it's fast, but because you have a lookup table.
It's not fast. It's small.
Yeah, it is small, and because you're generating a lookup table, it's not consuming the memory that you are consuming. So
yes,
it
I'm
might
consuming
help you.
65.
Yeah, so it might help you. And actually, this is a good example. Let's say that. So thank you, Proton, for that. So did you finish, or you want to say something else?
No. I'm done. Actually, I was reading this formula because I think it's taking advantage, but not the divs. Okay, it's using LSR to div. It's not bad, this formula. It's not bad at all. Should work.
Definitely, it will work. So,
yeah, give it to me. Paste on Telegram.
I will after the stream. Yeah, I will.
I can make some performance comparison, and then pick the best version for me. But still, I want to be very fast. I think mine is faster, but it consumes memory.
Yeah, it could be. I think you have to evaluate what works best. I hope you enjoyed this stream. Thanks again, Proton, and thanks again also Ozzy for sharing this information. We will continue with this series, episode number 12, where Ozzy will probably tell us, oh, I solved the game and now it is doing things, following the path as it should. So
the goal is to have at least half lap.
Something.
Running.
Anyway, guys, thank you very much. I hope to see you this Sunday on my next stream. And see you guys. Bye-bye.